Hello, hello, hello. Welcome back. It is Monday, the 27th of April, and today we're getting back into the A-level live solves. So I know over Easter I had no time. So I was like, oh, okay, I don't have time to go through like a full A-level paper. Let's just put some GCSE papers out. Turns out the GCSE papers took exactly as much time, but I thought it was a worthwhile diversion for my students who were doing GCSE math to get to pick up on that checking technique. So I just sort of got that out the way, but now we're back into that good old Edexcel solve series. Because I know I did the 2024 series. Now I'm finishing off the 2023 series. I might dip back across into the OCR when I'm done, although it's not my favorite. Edexcel is like top shelf for me. But yeah, so today's the stats in Mech. I've got my calculator. I should probably get the other calculator as well because I know stats is very like, do you press the right buttons? But also, I'm so famously bad at pressing the buttons that maybe like, if you all have your fancy CG50s, maybe you just know how to press the buttons on your own. I also don't think that's very entertaining, is me getting a bunch of calculators out. And it's like, oh guys, look at me press buttons. Isn't that what you're here for? No, no one has ever wanted to watch me press buttons. At least not literally. Socially, that's a different story. Oh, we have someone in the comments. UCL just. Oh, if UCL just put a bunch of offers out, because I know some people like have been waiting on like UCL and LSC. Was it LSC? Like I was speaking to a guy who's like still got 2 university offers outstanding. And I was so surprised about that this late in the game when the deadline is like so soon. Yeah, yeah, mass rejections. Like, well, maybe they've just like made up their minds. So maybe they've been slow rolling the maybe they've just been slow rolling the offers, and now it's time to like tell everyone who didn't make it that they didn't make it. Sorry if you didn't make it. Yeah, it's because this is the thing. At least with A-level results day, you know when A-level results day is gonna be. Whereas with the university offers, they kind of just trickle through and they never really tell you. And you just kind of like, I think I'm gonna get them maybe by the deadline. Of course, the deadline being right in the middle of exam season when you have other priorities. So it's just a deeply unhelpful process. Well done, admissions team. Go you. Well, if you didn't make it, then I'm here to give you a welcome distraction, which is working on your ability to get the offer for the other universities who did have the good sense to give you one. So let me get you guys over here. I'm probably going to have to do whole screen for this so that I can get the calculator out as required. I will. Do you know what? I will. I'll be good to you guys. I'll open the CG50 just in case the mood strikes me. So CG50 emulator is coming up. And if I share the entirety of this screen, just so that the calculator can come out. In fact, what I'll do, because I just don't like having the messy sidebar at the bottom. What I'll do is I'll do just the window for now for the the mech side. When it comes to the stats side, then I'll have to sort of rearrange it. I will get the timer up and running. So putting 2 hours on the clock total. Should be looking to spend about an hour on each, but I'm going to do them both and then mark them both. That's a mark scheme. That's a mark scheme. Guys, that's a mark scheme. So that's the formula book. So I'll put that as a buffer in between. So we've got our Mech paper, and let's get into it. Starting the clock. And question 1. All right, this is immediately SUVAT. No big challenges here. So we're initially at rest. We're accelerating with an acceleration of 3.2. I really want to have a good like events and episodes question. But if we don't, then at least we got this sort of basic SUVAT. With SUVAT, you always write out your SUVAT values. So it's after 5 seconds. Acceleration is 3.2. Starts from rest. So V is equal to U plus AT. I know they're basic, but do start by quoting the full Suvat equation before you plug everything in. 3.2 times 5 is 16, I think. Let me just confirm. Yes. So V equals, no. V equals 16 meters per second. And the distance traveled, so S is equal to UT plus half AT squared. These Suvat equations are given in the formula book. They are given in the formula book. I do recommend memorizing them just because you use them so much. So that's 0 plus a half times 3.2 times 25, which when I run that, there's no... This is what I mean. Like, I don't feel any need to demonstrate that I'm able to press these buttons. There's no skill in that. You know how to press these buttons. I think when it gets into stats distributions, that's when you got to sort of show it. All right. So nothing too outrageous there. I'm also now getting super paranoid that these are AS papers. Hold on a minute. No, it's advanced. That is a full A level. I'm like, why are these questions AS questions? Okay, so this looks immediately like it's going to be some sort of F equals MA situation. So it's got a mass of 5, rough horizontal plane, horizontal force of 28. The only resistance is a frictional force magnitude F. Find the magnitude of the normal reaction. Well, there's absolutely no prizes for that because there's a weight of 5g acting down and there's a reaction force acting up. And if we resolve vertically, we know it's not accelerating vertically. So the net force is 0 vertically. So it means that R minus 5g equals 0 and R is just equal to 5g. Now, the particle is accelerating along the plane at 1.4 meters per second squared. Find the value of F. Well, that will be from resolving horizontally. And if we resolve horizontally, then we have 28 minus F is equal to MA. I should really have started by quoting the equation, F equals MA. Sue me. So it equals M times A, which is 1.4. Yeah. So 5 times the 1.4 gives me 7, which means that F is equal to 21 newtons. The coefficient of friction is mu. Find mu. Well, it's moving, so it's F equals mu r, as opposed to when it's stationary, where you have to consider if it's less than or equal to. So here, the frictional force of 21 is equal to mu times 5g. So mu is equal to 21 all over 5 times 9.8, because we use 9.8 in stats and mech, as opposed to the 9.81 you would use in physics. And I literally, as I said that, I nearly typed in 9.81. Okay, so that gets me 0.43. So two significant figures. Okay. Now, question 3. There we go. This is more fun. Okay, so this is a velocity vector, and it's asking me for the speed. Immediately, I'm thinking speed is the magnitude of the velocity vector. So if I plug in fact, I got to zoom out a little bit. If I plug in t equals 0, the velocity vector will be 7I minus 3j. And so the speed will be you get that from Pythagoras. So speed would be the square root of 7 squared plus 3 squared. So root of 7 squared plus 3 squared is root 58. Hold on a minute. Yeah, I'll leave it exact. So that's going to be A. Then B. The value of t when p is moving parallel. Okay, a lot of people get really tripped up by this. So when something is in vectors, when two vectors are parallel, that means they are multiples of each other. So when p is moving parallel to I plus j, it means that the velocity vector at time t is a multiple of I plus j. So it means that if I write out this full vector, so it's t squared minus 3t plus 7. So it's that many i's, and 2t squared minus 3 lots of j. All right, so that guy is going to be some multiple of I plus j. So in other words, it just means that if we compare I and j parts, t squared minus 3t plus 7 would be equal to that multiple, but so would 2t squared minus 3, which basically just means I equate the I and j parts together. So this thing will equal to so the j parts will be equal to the I parts, and then that should just get us a nice, easy quadratic. Nice. So that's going to give me t plus 5, t minus 2 equals 0. So t equals minus 5 or t equals 2, but t has to be bigger than 0, so t equals 2. Okay, first of all, look at how I arrange my work. You see how there's like ideas and then a break, and then almost like a paragraph and then a break, and then I do a different sort of chunk of work, and then I leave a break. The way you present your work on paper is not just to help the examiner see what you're doing, it's also to follow your own train of thought. And I recommend you guys, especially at this stage of exam season, start to think about that. Also, I've got to a next checkpoint. I've got a time, but I've forgotten what the question was. So I should really now go back, reread it, make sure I know what I'm actually asked for. So I was asked for the value of time and not the velocity vector, so I have finished, but always worth checking. All right, so for C, we know that the acceleration is the derivative of the velocity vector. Apologies, got to take that. It's a quick scheduling thing for a student later today. Exam season is always in flux. Okay. Okay. So back to this. So we differentiate the velocity vector. And again, I'm just going to rewrite the velocity vector just so that I know what I'm working with. So the velocity vector was t squared minus 3t plus 7, lots of I, and it was 2t squared minus 3 lots of j. Right, so the acceleration vector is the rate of change of the velocity vector. So it's 2t minus 3 lots of I, and it's 4t lots of j. And we need to find the acceleration vector. Well, that's it. And then find the value of t when the direction of the acceleration is perpendicular to I. So if it's perpendicular to I, that means it's purely j, which means the I parts are 0. So that means that 2t minus 3 would equal 0, so t is equal to 3 over 2. Great. So we have now a particle moving on a smooth horizontal plane with a constant acceleration. As soon as I hear constant acceleration, I think CVAP. So at time t equals 0, we're A. At t equals 5, it's B. Velocity at A, so that's going to be our U. Okay, so let me write down what we know. So this is, okay, there's going to be a point C. So this will kind of be events and episodes. So to go from A to B, what's up? I'm going to write out the CVAT. A is 2.4 I plus J. Yeah, I agree. Well, Edexcel stats and Mech questions, it can have the easiest one as ever until like the one at the end where they decide to really go off. I will also say their further mechanics is a lot harder, obviously on account of it being further. But still, I think the principles stand here. So, but also bear in mind, hold on, just because it's an easy paper does not mean it's going to be easy for you, because everyone sits the same paper and there's somewhat of a sort of grade boundary curve situation. So what's going to be really important if you find an easy paper is to make sure you're executing with complete accuracy, which is why the checking matters. If it's easier, you'll get through it faster. You'll have more time at the end to check it. Yeah. So here, u is equal to minus 16 minus 3. Okay, and t equals 5 to get from one to the other. Time is a scalar, so it's not a vector. We want to find the speed of p. So what we're looking for is the v vector. So v is equal to u plus at. So it's minus 16i minus 3j plus 5 lots of 2.4i plus j. So it's minus 16i minus 3j. Now 2.4 times 5 is 12. And 5j. So it's minus 4i plus 2j. Cool, so that's v. But it didn't ask me for the velocity vector, it asked me for speed. So again, I've got to take the magnitude of that, and it's the root of 4 squared plus 2 squared, which I think is going to be 2 root 5, but let me confirm. It is 2 root 5. And I'll put the meters per second as well. So that's the speed as it passes through B. So that's A, this is B. Find the position vector of A is that at time t seconds bigger than 5, it passes through C. So what I can say here is that I need the displacement vector between A and C to start with a minus 40i. So let's do that. Let's get what the A to C vector is. So the A to C vector is minus 40i. And then to get from there to there, you have to add on 10 and then a further C. So it's a 10 plus CJ. And for the A to C episode, I can lay out a new suvat where I still have my constant acceleration. This is my displacement vector. My u is the same u as it was before because that is the velocity at A, which is minus 16 minus 3. We don't know the time. I think we're working out the time. Yeah, at some time t bigger than 5. So that'll be s equals ut plus half at squared, where you're going to have to account for the fact. Well, in fact, no, I think I'm going to have to do it just in the I parts, maybe. We'll see. I'll lay it out in full and just sort of see what happens. So what I'll have is s equals ut plus half at squared. I'm also thinking the reason why they said it has to be bigger than 5 is because we'll get 2 answers. So minus 40i plus 10 plus c. In fact, let's get some exam technique. Are we going to find c later? We are finding c later. So it is very much going to be comparing I and j parts, but I'll do this early legwork and then carry it through onto part C. So s equals u t plus a half a t squared. So in fact, I'll just go straight to the I parts now. So comparing I parts, which I'll even write my intentions here. So comparing I parts, we have minus 40 equals minus 16t from these I parts plus 1.2t squared from the I parts of the second bracket. I wonder if do these things divide by 1.2? 40 divided by 1.2? No. So we have 1.2t squared minus 16t plus 40 by adding that to the other side. No sign errors. That's equal to 0. Let me see if this factorizes. So I'll first multiply by 10. Then I can divide by 4. Now, realistically, in the real thing, would you probably just reach for your equation solver? Maybe, but I think showing the steps is more likely to pick you up method marks in case something goes wrong. So at this point, I might be tempted to pop it in an equation solver. But why? So 300, okay, so target number 300, things that multiply to 300, and the factors have a difference of 40, so that'd be like, yeah, minus 30 minus 10. So it would be 3t and t, and it's going to be minus 10 minus 10 equals 0. So either t equals 10 over 3, or t is equal to 10. But again, because t has to be bigger than 5, t is equal to 10 seconds. And if t is equal to 10 seconds, we can plug that in for the j parts to work out what the c is. So 10 plus c is equal to minus 3t from the j parts of the first bracket and 0.5t squared from the j parts of the second bracket. And we said that that t was equal to 10. So we can plug that in. Minus 30 plus 50 equals 20. So c is equal to 10. I'm going to want to check that afterwards because that all felt too smooth. And the number is too convenient. But, oh, hello. This looks more fun. Come on, projectiles. So a small ball is projected with a speed of 28. Speed, not a velocity. After moving for t seconds, the ball passes through point A. The point A is 40 meters horizontally, 20 vertically, as shown in the diagram. Cool. Particle moving freely. Find the time. So this, okay, let's use some exam technique. I'm immediately seeing that's cos alpha. And cos alpha would make this horizontal, so that's incentivizing me to consider the horizontal components first. I could, to be honest, I'll probably just end up doing it all on the diagram. No, I'll do, okay, so remember, when you're doing projectiles, vertically, you're always doing a suvat. And horizontally, you're just doing distance equals speed times time. So horizontally, we're going to say, so distance, speed, time. The distance, I think, was 40. This horizontal speed was 28 cos alpha. And the time is what we're asked to find. So it's very simply a case that distance equals speed times time. So the time is equal to 40 over 28 cos alpha, which is 10 over 7 cos alpha, which is what they wanted. Cool. So now for 5 marks, we've got to show that this thing is doing stuff. So I'm going to assume that we've now, because we've done the horizontal, now we consider the vertical. So that's A. Now the vertical is, so it's 20 up, it's 28 sine alpha up. Now I'm saying up because I'm always considering the direction, so I know whether something's positive, negative. For instance, I know that A is equal to 9.8 down, which is why it's negative, and I know it has the same time. And then if I put all that together, S equals ut plus half at squared. And the S is 20. So it's equal to 28 t sine alpha minus 4.9. Hold on, where's my eraser? T squared. And if I substitute in, that's going to get me 28 10 over 7 cos alpha times sine alpha, which is good because that gets me one of my tans. Minus, oh, this is going to be so nice. Because that's going to be 100 all over 49 cos squared alpha. And the reason why I say that's nice, first of all, 7 cancels there to make that 4. So I'm going to get 40 tan alpha from this. But from here, well, first of all, let's deal with the numbers. I can deal with a 10 from that to make that 49, which will then cancel with that. So I'm going to get a 10. But then that's sec squared alpha. And I can never, so sine squared plus cos squared is equal to 1. To get a sec squared, we're dividing by cos squared. So a tan squared plus 1 equals sec squared. That is going to get me something in tan. So sec squared is tan squared plus 1. I'm also going to divide through entirely by 10. So 2 is equal to 4 tan alpha minus tan squared alpha minus 1, making sure to remember to multiply that minus 1 into the bracket. So then we've got tan squared alpha minus 4 tan alpha plus 3 equals 0, which is exactly what I wanted to get. Love to see it. So find the greatest possible height. I assume that's going to involve solving for tan alpha, but also max height. Let me just for peace of mind, let me write out the conditions for maximum height. So that was B. For C, I would want a different vertical suvat. So that would be the height H. You would still be equal to 28 sine alpha. V is equal to 0 at maximum height, vertically speaking. And the acceleration is still minus 9.8. So this would be, for the first time, v squared equals u squared plus 2as. So 0 is equal to 28 sine alpha all squared. So minus 19.6h. So I know, well, what's 28 squared? I know that 19.6h is equal to 784 sine squared alpha. So h is equal to that divided by 19.6. So it's 40 sine squared alpha. So now I'm going to have to find from that quadratic, because I'm sure it wants me to find the actual maximum height. Yeah, in meters. So I'm going to have to solve the quadratic, get a sine squared from that. So we know from the quadratic that tan alpha minus 3, tan alpha minus 1 is equal to 0, which means that tan alpha equals 3 or tan alpha equals 1. Also, if you're more comfortable, a lot of people would want to substitute in there and say like y squared minus 4y plus 3 equals 0 for the stealth quadratic, then solve from there. I'm confident going direct to it, so that's what I'm going to do. Inverse tan of 3 is, so this would give an alpha in degrees. Do I want to actually do that though? No, I don't. Because, hold on a minute. First of all, why do I get 2 answers? It should only be one of them. Why are there two? Why does one of them not work? It's not gonna work because of maybe because of this t squared situation. But I don't see. I mean, just from looking at it, looks like tan alpha doesn't equal 1 because that would be 45 degrees. But I don't know what exactly the problem would be with that. Hmm. Okay, well, let me tell you what I'm thinking first of all. So let me first solve them both, and maybe one of them isn't real. Maybe one of them is less than 20. Let me say. So as soon as I see this, what I would want to do actually in mechanics, when you're converting between sine, cos, and tan, you want to draw representative triangles. So what would be a triangle for which tan alpha equals 3? Well, that would be opposite. That would be hypotenuse. This would be root 10. So from this, I can get that sine alpha would be 3 over root 10. So sine squared alpha would be 9 over 10, which is quite cool. So sine squared alpha would be 9 over 10, and h would therefore, multiplying that by 40, be 36. Now on this one, this would obviously, this is your 1, 1 root 2. This one here would give us sine alpha is 1 over root 2, and a sine squared alpha is a half, and h would be equal to 20, right? But we know the max height has to be bigger than 20. Because that's not, yeah, it's clear from the diagram that's not max height. We need, so I'll say that explicitly. So we need h to be bigger than 20, therefore h is equal to 36 meters. It's not a problem until it's a problem, and then it'll sort itself out. So the model does not include air resistance. State one other limitation of the model. It considers the ball as a particle with no volume, and therefore doesn't consider spin. I'll just say that. And in fact, I'll write that up there. So one limitation of the model, it does not consider volume of the ball. So I'll say shape or volume. Of the ball. So if it doesn't consider the shape or volume of the ball, it means that it doesn't consider the spin. And whether that would affect anything. So I think that one should be safe, although I'm notoriously bad at getting the wordy questions right in Stats and Mech. So we'll see. Yes, ladder problem. There we go. This is going to be fun. So we have a rod AB of a mass M. I'm going to assume it's uniform. Is it not uniform? Oh, in the new model, it's non-uniform. So in the original model, it should be uniform? Okay, no, I'm getting ahead of myself. Okay. Just answer the question in order. State the direction of the frictional force acting on the rod at A. Give a reason for your answer. It's acting to the right because the rod is trying to slip left, and friction opposes motion. So I'll say trying to slip left. Friction opposes motion. And therefore, friction is acting to the right. So the magnitude of the normal reaction of the wall on the rod at B is S. The vertical wall is smooth, so there's no friction vertically. We know we're going to have a reaction at A. We know we're going to have friction acting to the right. We know we're going to have weight at some point. We're modeling it as uniform for the purposes of this question. Cool. Well, for this part of the question. So M is going to be there. And for the purposes of this part, this would be split into A and A. With any moments question, I always advise drawing on your local distances so that you don't have to deal with any extra arrows, which would confuse with force arrows, telling you what distances there are. And every time I look at it, I know it's just going to be between the two most immediate points. It means I don't have to bother thinking about anything. Because thinking, why would you want to think in an A-level math paper? Outrageous. So we want to take moments about A to show that S is equal to some stuff. Right, so taking moments about A, we can see that, well, there's two ways of doing moments. You either resolve the distances or you resolve the forces. In this case, because the forces are vertically and horizontally, I'm going to want to resolve the distances. So that's M acting at a perpendicular distance of A cos theta. And that's S acting at a vertical perpendicular distance of 2A sine theta. And because it is in equilibrium, the moments will be balanced. And so M acting at the distance of A cos theta is equal to S acting at the distance of 2A sine theta. And we can rearrange this for S and say that S is equal to MA cos theta all over 2A sine theta. These will cancel, so it's a half M cot theta. I forgot my G because I'm a silly. So that's a force. Thank you, show that. That is something that would not have got picked up on my checks. So I'm glad I saw that. So it's mg as required. Oh, apologies. I forgot to turn off the radio alarm. I shall be back in a momentarily. Love when things take you by surprise like that. Hopefully it wasn't too much of a disturbance. Back into it. So that is B. So we've got that. Half mg cot theta. Coefficient of the friction is mu. Tan theta is stuff. Find the value of mu. Okay, well, as soon as I see that, tan theta is 3/4. I'm immediately going to do my resolving triangle just to work out sine and cos. Apologies, it came back on again. I'll be back in a sec. We are live, baby. This is what happens when you do spontaneous streams and forget that you set alarms. So tan theta is 3/4. You've got your theta. Opposite would be 3, adjacent would be 4. This is so totally to scale, guys. And this would make that a 3/4/5, which means that cos theta is 4/5 and sine theta is 3/5. Cool. We also know, therefore, that S would be equal to a half mg. Cot theta is 1 over tan, so that flips that around to make it 4/3, which makes the whole thing 2/3 mg. So we've got our S, we've got our mg, and we've done moments. So the next thing to do is to consider resolving vertically and horizontally. So vertically speaking, we're going to have R equaling mg. And horizontally speaking, because it is in limiting equilibrium, is it? Wait, am I doing? Yeah. Given that tan theta is that, find mu coefficient is friction is that. The rod is in limiting equilibrium. Good. So because it is in limiting equilibrium, the friction is mu r, and that would be equal to the horizontal reaction force of S. So we at that point we will have considered that the moments are balanced, that the vertical forces are balanced, and that the horizontal forces are balanced, which means that mu times mg is equal to 2/3 mg, which obviously means then that mu is equal to 2/3. Okay, and then D, find in terms of m and g the magnitude of the resultant force acting on the rod at A. Okay, well, what's happening at A? We have mg acting up. We have 2/3 mg acting to the right. So we just have to bring those components together. So I'll sort of demonstrate that here. So we have 2/3 mg. We have mg, and we do the Pythagoras on that. So that's the vertical component, horizontal component. So just the magnitude of the resultant force. So the magnitude of the resultant force is the root of mg squared and 2/3 mg squared. So in other words, it's going to be m, and I can take the mg out of that. So it's the root of 1 plus 2/3 squared. And when I run that in the calculator, I get root 13/3. So that is the resultant force at A in terms of m and g. So now the rod is non-uniform, with its center of mass closer to B than it is to A. Okay, so I'm going to move. In fact, I shouldn't even have done that. Let me undo that. What I should do instead is just change the distances. So it's closer to B than A. Oh, this is a state. This is fine. A new value for S is calculated at the same angle. State whether this new value for S is larger, smaller, or equal to, give a reason. Right. Well, this is going to be done from moments, the moments balance. If it's closer to B, that means the clockwise moment from the weight has increased, which means that the counterclockwise moment from the reaction force has to increase to balance it, which means that S has increased. Okay. So if weight closer to, I'll say, yeah. So I'll just basically say all that out again. So weight closer to B increases clockwise moment. Well, no, I'll just say it. You guys, okay, it's what I'm saying. So it increases the clockwise moment of the weight about pivot point A, which means that in order to stay in equilibrium, it's that. I've explained it. Okay, I get the mark. Fine. All right, so that's 6 done. Let's stop sharing that. Let's start sharing the whole screen so that I'm able to bring in the calculators as required. And let's go and do the stats. How am I doing on time? Great, that's 40 minutes in. Okay, let's get into it. So Venn diagram right off the bat. We know that the sum of the probabilities is 1. Find the probability of A. Well, that's just the sum of these two. So this is going to be great fun. So you add up the two probabilities in A, and we find that the probability of A in total is 0.38. So now events B and C are independent. Now, the independence test is a very simple thing. So because they are independent, that means the probability of B and intersection C, what's happening? B intersection C is probability of B times the probability of C. So the probability of B is the sum of these guys. So it's the 0.25 plus the 0.05 plus the 0.3, which is 0.6. The probability of C is 0.3 plus P. And the probability of B intersection C is 0.3. So 0.3 is equal to 0.18 plus 0.6p. 0.12 equals 0.6p. P is equal to 0.2. Now the sum of the probabilities is 1. So 0.13 plus 0.25 plus 0.05 plus 0.3. So that's already, and we also know that this 0.73 plus the P plus the Q will equal 1. So 0.93 plus Q equals 1, and Q is equal to 0.07. Okay. Now, conditional probability, find the probability of A given not B. So as soon as I see that, given not B, that determines where I look. So I'm looking in not B. So I'm looking out of these guys. So out of these guys, find the probability of A. Well, first of all, what's the probability of not B? It'd be 1 minus 0.25 minus 0.05 minus 0.3, which would give me 0.4. There's also the equation I can use from the formula book. Let me see if I can find it. Let's say as further. So I want, yeah, this conditional no, yes, no, that's theorem. Oh, they actually don't give. Maybe they give it in the AS. I would be very curious if they didn't. They actually don't. So maybe you got to know this one. All right. So here, probability of A given not B is probability of A intersection not B all over the probability of not B. So what is the probability of being A and not B? That is this 0.13 all over the probability of being not B, which is 0.4. And you can rep that. You can also think of it conceptually. Once we plug these in, we're looking out of the 0.4 and we're trying to find this 0.13. So you can do it just based on what you see in the Venn diagram, or you can do it based on the formula. Either way, you get the same answer. 0.13 divided by 0.4 is, I'll give it exact, is just, 13 over 40. All right. So then, a machine fills packets with sweets. 1/7 of the packets contain a prize. Packets of sweets are placed in boxes before being delivered to shops. 40 packets of sweets in a box. So there are 40 packets. Some of them contain prizes. Probability should be 1/7. State a condition. Right. So remember your 4 conditions for binomial. Fixed number of trials, fixed probability of success, only 2 outcomes, success or failure, and by far the most important, independence. So stating a condition for 2A is going to be that packets have prizes independently. So one packet having a prize does not affect the probability of another packet having a prize. So a box is selected at random. We've got our binomial distribution. It is calculator time. Find the probability that a box has exactly, well, as soon as it's exactly, that is going to be the binomial PD, which is going to be this number 4. So PD gives exact. Let's do variable because we don't need a list. We want to find exactly 6 with 40, and probability is a 7th. And we get this, so I'll just write that in. 0. I forgot it does that. All right, so 0.1727, giving all probabilities to 4 decimal places. Now here, the probability that the box has fewer, so this is the probability that T is fewer than 3. Well, that is the probability of being less than or equal to 2. So I'd like to draw a number line here. So 3 is out, 2 is in. So it's less than 3, so it's less than or equal to 2. And that matters because that is what the binomial CD gives you. The CD is strictly less than or equal to. So again, from the list. Nope, not from the list. How do I go back? Oh. Oops. Binomial CD, it's a variable. We don't need a list. So in this case, we want less than or equal to 2. For n is 40, and the probability is a 7th. I'll just again make that explicit. That is 1 over 7. And that is 0. One of these days, guys, I'll learn. So 0.06. Ooh, sorry, something in the chat. Nice of you to finally do an Edexcel paper. You say that. This is my 6th Edexcel paper, I'll have you know. So this is my final of the 2023 summer series, but I also did the full 2024 summer series. It's just been a while. Okay. Sweet shop buys 5 boxes of the sweets. Find the probability that exactly 2 of 5 have few. Okay, so this is what I call a nested binomial. So in the first one, it was distributed with T. So now let's say that X is the distribution of the number of boxes having fewer than 3 packets containing a prize. Well, that's out of 5 boxes, so n is equal to 5. And what is the probability of one of those boxes having fewer than 3 packets? It's the 0.0616. And we want to find the probability of X being exactly 2. So we will put that in. In fact, I wonder if I can just put that in as an answer. We're about to find out. So 7, this is binomial PD variable because we want it exact. X is equal to 2, n is equal to 5, p is equal to, I really don't think it will let me, but I'll try it. Oh, it will. And then equals. Oh, one of these days I will learn 0.0313. Right, Camille claims that the proportion of packets containing a prize is less than a 7th. This is sounding very hypothesis testy. Yep. Random sample of 110 is taken and 9 contain a prize. Use a suitable test. Okay. State your hypotheses clearly. So H0, the probability is a 7th. H1, the probability is less than a 7th. We're going to assume it is a 7th, 110 packets. So we're going to now do Y is distributed binomially because T and X are taken. 110 packets, probability of a 7th. 9 contain a prize. This is a left tail test. So again, I'm going to draw my number line here and say that our evidence is 9. So what we want to do is work out the probability of getting 9 and less and comparing that with the 5% significance level. So there's some line in the sand where the distance from there to the end is 0.05. So by finding the probability from 9 to the left end, we can find out which side of this line in the sand we are. So let's work out the probability of being 9 or less. So the probability that y is less than or equal to 9, I'm going to bring this across. And we're going to do the CD again. We're going to do variable. X is equal to 9, n is equal to 110. Probability is a seventh. And we get that probability is... I text so bad. 0.0383. Now that matters because this line in the sand is 5% at the end. 9 is only 3.8% at the end. So in other words, because that probability is less than that, it is sufficiently extreme, and we do reject. So we reject H naught, and we conclude that Camille is right, that the probability is less than a seventh. Okay. Now you can see, look at all this space I didn't use. Okay, so here, daily total rainfall. So this is the Edexcel large data set, which I hope you guys know. He used all the data from the large data set, summarized it below. Trace, remember, is between 0 and 0.1. Also remember that these are to the nearest 0.1, which means that actually 0.05 will round into this bucket. So trace is between 0 and 0.05 millimeters. So explain how the data will need to be cleaned before Ben can start to calculate statistics such as the mean and standard deviation. He needs to handle the trace. How do you clean the trace? Do you get rid of the trace? Well, no, I suppose you... Maybe, I'll be curious to see a mark scheme on this. I'm going to say that trace is between 0 to 0.05 millimeters. And you also need to round... So in fact, hold on, let me write this below. So trace equals 0 to 0.5. Well, 0 less than or equal to, not equal to, bigger, that's strictly bigger than, x less than, and again, strictly less than 0.05. So that's the first point. The second point is we need to make the values continuous. So we need to, for instance, so I'll call it make the regions continuous. So right now, these are to the nearest whatever. What happens if you have 0.54? So you need to consider the second region of being 0.05 to x to 0.55. So that's the second thing. All right, so for B, although do you need to do that to clean it? Not for mean and standard deviation, I don't think, because for mean and standard deviation, you just consider the midpoints of the regions, which are unaffected by the rounding. I suppose not the trace. I don't know. I hate words. Guys, I hate the words so much. We'll see what they say in the mark scheme. Stats and mech, you can have my marks. I'll get 100% in the pure. So how much... okay, so that's kind of what I'm thinking about A. So using all 184 of the values. So, okay, we definitely don't get rid of the trace. So that is how we consider trace to be. So we get to calculation, calculate estimates for the mean daily total rainfall. So the mean is the sigma x over n. So the sigma x is 390. The n is 184. So 390 over 184 is 2.12. How do they want this quoted? I'll just do that. 2.12, and it's millimeters. Let me just check that these are given. So the standard deviation is given here, but the mean is not. The mean you have to just know is sigma x over n, but you do at least have the standard deviation here in the formula book. So the standard deviation is the root of, so it's the mean of the squares. So it's sigma x squared. So it's 4336 all over the 184 minus the square of this mean. And I'll do it precisely to avoid any issues. So the root of 4336 over 184 minus that thing squared is 4 point. Damn, that's a big standard deviation. 37. As soon as I see a standard deviation bigger than a mean, I'm like, whoa, you got some variance on your hands. Can that be right? That feels too big, though. I suppose if you can get all the way up to 32, that's what's dragging it out. Suggest that the statistic calculated in B1 to estimate the annual mean rainfall. Right. So the thing you have to understand about the large data set, give a reason why it's not. So this is between May to October. And I might expect May to October to have less rain than average. So instead of this, if you want, it's not true that necessarily the entire year would have that at the average when you're going through the summer months. So first I'll just show them. So yeah, it's May to October. Might have less rain on average than the whole year. So in other words, it's not representative. Some are not representative. I'm sure that should be sufficient. Right. Also, what I'm going to do is I'm going to go over here into the mech and save that. Cool. So here, state giving a reason how you would expect the estimate to differ from the actual. So B part 1 would be less than actual. Okay. Right. Question 4. Study was made of adult men from region A of a country, found that the heights are normally distributed with a mean and standard deviation. Right, well, this is going to be fairly simple. So now I'm going to go into distributions. This will be normal CD. We will never use normal PD, so don't even worry about it. So this is going to be, so it's taller than 180. So the min is 180. The max is 9 times 10 to the stupid. The standard deviation is 6.8. The mean is 175.4. So that is, oh, guys, I finally clocked it. Got to move that over. Right, so that is 0.2494. A study claims that the mean height of adult men from region B of the country was different from the mean height in A. So this is, again, hypothesis testing. So let's go for B. So the hypothesis is that the mean is the same. The null hypothesis is that the mean Because remember, in a normal distribution, you're always testing the mean. So the mean is 175.4. And the alternative is just that it's different. So just that it's not 175.4, two-tail test either direction. So we are going to assume a normal distribution with a mean of the null hypothesis, and the standard deviation as given is 6.8. I'm going to draw a curve so I understand what is happening here. So 175.4, and we have evidence of 177.2, so that is here. So there to the end, we can work out that probability, and using a 5% significance would give me 2.5% in each tail. So let's work out, first of all, probability of x being bigger than 177.2. Like, there should really be a way to just go back. And I'm sure there is. I just don't know what it is. Oh, there we go. So now the lower is 177.2. The upper is 9 times 10 to the stupid mean standard deviation. Let's go. No, I did a silly, guys. All right, what did I forget? I forget what everyone always forgets in the normal hypothesis test. So hold on a minute. That is true of individual things. I forgot that we found a sample mean. Absolute donut. So an individual element still has 6.8, but for a mean, so for the mean standard deviation of the mean, that's equal to standard deviation over root n. So we have to have 6.8 over. Now, how many people were tested? 52 adult men. So that actually massively decreases the standard deviation. So the actual standard deviation of the mean of the sample is much smaller. So it's going to be 6.8 all over the square root of 52, which is 0.943 with a high degree of accuracy there. So if I come back in here, change that standard deviation to 6.8 over root 52. Yep. That's more like it. So therefore, oh, guys. Right. So the x bar will be distributed normally with the mean of 175.4, but a new standard deviation of the 0.943. In fact, that should always be squared for normal. So the probability that x bar is bigger than 177.2 is 0.0281. But because this is a two-tailed test, its significance is, for this particular test, 0.025 in each tail. This probability is too big. It means the actual significance level, if I kind of unsquiggle this in, the actual line in the sand is here. So the line in the sand I've just drew is the 0.025. The 177.2 is not sufficiently extreme. It's not past the line in the sand. So therefore, do not reject. Cannot conclude that the mean height is different. So it's always do not reject H naught. So you always have to say theoretically what that means for the hypothesis test, and then finally what that means in terms of the interpretation. So that means cannot conclude the mean height is different. Okay. Oh, am I done? Why am I? Oh, whoa, 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 whoa. You see, this is why the second you think you're done with a paper, you check to make sure you've answered every part of every question. Look at me racing off. Find the p-value. What does that mean? What? What does the p-value mean? I've genuinely never heard of that. The p-value? Maybe that's the probability. Maybe I don't know. Maybe they wanted me to do it from critical region. I swear to God, I've never seen that. So I'm so looking forward to the mark scheme on that. What is that? What's the p-value? Guys, no spoilers in chat because I want to know what I actually would have got. But like, nah. All right, so this is more fun. This is probability distributions. I know the sum of the probabilities is 1. We can give up and go home now. Cool. Ball, cup, spinner, variable x. Okay. Let's play the game. The spinner is spun to obtain a value of x. X centimeters from the cup and tries to throw the ball in the cup. The event S represents the event that they successfully throw the ball in the cup. The probability of event S, so success at a given distance is given by this. What? Okay. So this is a bit weird, but let's have a go. So these are the probabilities of getting the x values, and then there's the probability of success given those x values. So I'll write here as well, probability of succeeding at that given x. So that would be k over 20, k over 50, k over 80, k over 100. So we can very easily work out k. Because the sum of those probabilities should be 1. So if I add up 1 over 20 and 1 over 50 and 1 over 80 and 1 over 100, I get that they sum to 37 over 400k, which equals 1. So in other words, k is equal to 400 over 37. So we can work out these exact probabilities. So that thing divided by 20. So this one here is actually 20 over 37. 400 over 37 divide 50. So this one here is 8 over 37 divided by 80 will give you 5 over 37 and then 4 over 37. So that's the probability of succeeding from those distances. Okay. So I think from this second point that these probabilities times these probabilities should all be equal, and they want you to compare C and B. For 2 marks, I feel like this shouldn't have been that complicated. I probably overcomplicated it, but for A, we're going to say that 8/7 times B, sorry, 8 over 37 lots of B is equal to 5/37 lots of C. And therefore B is equal, so C is equal to 8 over 5. So yeah, multiply both sides by 37 and then divide both sides by 5 and you get this. Maybe it was what you had to do. I mean, I'm satisfied with it. It's mathematically rigorous. Find the probability distribution of X. Oh, oops. I done did the thing already. So I did them in the wrong order. That's fine. I've now done that. Oh, no, of X. I've done the probability distribution of S. I've not done it of X. Oh, this is going to be such a nightmare. Right, well, okay, hold on. I've done C in terms of B. I wonder if I can do the others in terms of B. So I know that, for instance, getting rid of my over 37, I can say that 20A plus 8B. Oh, no, I absolutely did need to do that, I think. So 20A equals 8B equals 5C. Equals 4D. And that comes from this bullet point here. This is interesting. Actually making me think. Equals 4D. And A plus B plus C plus D equals 1. So let's get them all in terms of something. I would prefer to get them all in terms of D, personally speaking, because I know from this that... Oh, no. So get them all in terms of A, maybe? So, for instance, I know that 20A equals 4D, which means that D is equal to 5A. I know that 20A equals 8B, which means, so 20 over 8, so it's 2.5, it's 5 over 2. So I know that B is equal to 5 over 2 lots of A. I know that 20A is equal to 5C, which means that C is equal to 4A. We can plug that all in and say that A, let me just zoom in a little bit, say that A plus B plus C plus D equals 1. So that plus 4 plus 5 plus 1 is 25 over 2A equals 1. So A is equal to 2 over 25. So if A is equal to 2 over 25, then B would be equal to that times would be equal to 125 over 4. No, hold on a minute. That's not correct. So 2.5 times. Now, can I do this mentally? Yes, I just am feeling a bit lazy. So that's a fifth. C is equal to that A times 4, so that's 8 25ths. And D is equal to 5A, which is 2/5. Let me just confirm that these do in fact all sum to 1. So 2 over 25 plus a fifth plus 8 over 25 plus 2/5 does sum to 1. That's good. So I think, yeah, and realistically, I would just redraw the table with those probabilities in, but that'll be boring for you. Do you have any predictions for Edexcel? I never make predictions. My prediction is if you learn the syllabus, you'll do well. That is what I predict. Okay, so that's my probability distribution for X. Tries a large number of times to throw the ball into the cup from a distance of 100. Successfully gets it in 30% of the time. why the model is not suitable to describe nav playing for all values of x. Because from 100, d, the probability of success should be 4 over 37. And 4 over 37 is 10%. So that's actually much bigger. I'll write that in for C. Actually, I'll just write it on the paper. So that is 30% is pretty significantly bigger than 4 over 37. So the model does not predict reality. Okay. We'll see if that's what they wanted. Okay, so let's get the probably final question, question 6. Let me check that is is it the final? Damn, this is a long question. But it is the final question. Medical researchers studying the number of hours patient stays in hospital following a particular operation. Histogram on the page opposite, because we have a histogram. Use the histogram. Okay, so it's 90 patients total. And I know that on a histogram, people are represented by area. So this total area represents 90 people. And we need to work out the probability of being between 10 and 30. Man, that's going to be a pain. So the total area represents 90. We don't even need to know that, to be honest, for the first part. So all we need to say is that that probability is equal to the area between 10 and 30 all over the total area. But we do have a frequency density. So that's 2.5 times 4 point. Nope. What is this? Nope. That's 4. Yes. So 2.5 times 4 gives me 10. Although I shouldn't really. I'm faffing. I need to stop faffing. Okay. No, this will be fine. Okay. So what I should be doing is working out what's happening between 10 and 30. So 10 is down here. 30 is over here. So 4.2 times 2 which is that is 2, isn't it? Yeah, it's 2 wide. So that's 8.4. That's obviously not 8.4 people, but we're dealing with probabilities here. And it's not a full proper sort of like we're assuming uniform distribution within this, which clearly can't be true. So then that is 16, that is 12. So that's 4 times 4 is 16. Then that's 4 times 3.5, which is 14. Then that's 1 times 10, which is 10. So we add those all up, and it's 8.4 plus 16 plus 14 plus 10 out of the 90, which is 121 all over the out of 225. So, okay, for these 90 patients, the time spent in hospital following the operation, mean and standard deviation, with reference to the histogram, state whether or not the model could be suitable. Well, we would expect, this does not seem suitable because a normal distribution should be symmetrical about the mean. So not suitable, data not symmetric. You could also describe it as having a positive skew. So instead of being a balanced tail, there's a big pull towards the positive tail in the sort of extremes. Also, I'll say positive skew. The frequency polygon based on this histogram could be modeled by a curve with this equation. I love how they're like, ooh, integration. I think this is the first time I've seen someone have to actually integrate in stats and well, not mech, but in stats. So well done, stats, for trying to actually do something. So the integral from 0 to n of x e to the minus x. Oh, it's by parts and everything. Alrighty then. All right, so we are going to say that u is equal to x. In fact, I can zoom in now. So u is equal to x. dv dx is equal to e to the minus x, which means that v is equal to minus e to the minus x. And if I differentiate u, I get 1. So plugging that in, it would be uv. So that's minus x e to the minus x minus the integral of u dash v, so minus e to the minus x between 0 and n. 0 and n. So this is minus n e to the minus n minus, I plug that in, I get 0. Minus, now the integral of this would become e to the minus x between n and 0. So that's minus n e to the minus n. And I subtract from that e to the minus n minus the 1 that I get when I plug in the 0. So that's minus n e to the minus n minus e to the minus n plus 1. So it's 1 minus e to the minus n lots of n plus 1. Now, how do they want it quoted? Basically that. Okay, cool. Show that for Zhang's model, k equals 99. Okay. So the integral from 0 to n is equal to that. N is equal to 4 because time and hours at 4. So he's modeling it in terms of tens of hours, I suppose. Yeah, it's measured in tens of hours. So we're integrating between 0 and 4. So n is 4. And it should be, the integral should be 1. So the integral of k x e to the minus x between 0 and 4 should equal 1. But also I can take, so that's k times the integral from 0 to 4 of x e to the minus x dx. So that's k into 1 minus e to the minus 4, well, 5 lots of e to the minus 4. And the point is that that equals 1. So k equals 1 over 1 minus 5 e to the minus 4. 1 minus 5 e to the minus 4 gets me not what I wanted. Okay, back to the drawing board. The integral, interesting. So whoever was saying that they never have interesting hard questions in Edexcel, have fun with this paper. 34 minutes left. Why am I not getting this? So I did get that. And the integral between 0 and n is that, but here n is 4. Because the area under the curve should be 0. No, the area under the curve, it's a frequency polygon. The area under the curve should not be 1. The area under the curve should be 90. 90. I apologize. Okay. Because it's not a probability, it's frequency polygon. So actually, the integral, the total number should be 90. So k is equal to 90 all over that stuff. Equals, there we go. So it's 99.07. So it's, in other words, approximately 99. To the nearest integer. Okay, woo! Frequency polygons are not often done. So that was challenging. So estimate the, probably, okay, so the first one's nice and simple. So even if you couldn't get part D, you can skip ahead to part E. So normal CD, lower is 10, upper is 30, mean is 14.9. Nope, standard deviation is 9.3. Mean is 14.9. No, I am not getting the door because it's not for me and I refuse to be a concierge for the entire building. Oops, accidentally turned off the thing. So the lower was 10, upper is 30. And that probability is 0.6. Let me write that down. 0.6487. So Zhang's curve with this equation and the answer to part C. So the probability of that, so E part 2, so the number, if I integrate between 10 and 30, that should tell me the number of people. And I'll divide that by 99 to get a probability. So the integral of 99 between 10 and 30 of 99x e to the minus x, it's going to be equal to 99 into, so between 10 and 30, but we have to use our answer to part C, which is between 0 and n. So that would be the integral from 0 to 30 minus the integral from 0 to 10. So let me use my result from, here. So I'm going to remind myself that the integral from 0 to n yielded me a result of 1 minus n plus 1 lots of e to the minus n. Okay, so that's 99 into. This guy is going to be 1 minus 31 e to the minus n. And I'm going to subtract off the integral from 0 to 10, which would be 1 minus 11 lots of e to the minus, e to the minus 10. This should have been e to the minus 30. Okay. So that would be 99 into 1 minus 31 e to the minus 30 minus 1 plus 11 e to the minus 10. The ones cancel, so that's 99 into 11 e to the minus 10 minus 31 e to the minus 30, which gets me 11 e to the minus 10 minus 31 e to the minus 30. Oh. 0.0494. But is that a probability, or was that supposed to be a number out of 90? Because I thought that was meant to be a frequency polygon. Ah, it's tens and hours. No, it's tens and hours. Okay, so okay, I should not have done it between 10 and 30. I should have done it between 1 and 3. That's why. Okay, redo. Okay. So 1 minus 4e to the minus 3, 1 minus 2e to the minus 1. Okay, there we go. This is better. So it's so easy to make those mistakes of interpretation of the model. But like you could see, look at how I was sense checking my results. I was like, that doesn't seem right. A lot of people would look at that and go, oh, that looks like a probability. That must be the probability. But I remembered the story of the question and that actually it was meant to represent a frequency, and have 0.05 of a person in that seemed off. So 2e to the minus 1 minus 4e to the minus 3. Right, let's run this now and see what I get. 99 into 2e to the minus 1 minus 4e to the minus 3. There we go. That's more like it. So that's 53.12 people. So the probability should be that 53.12 out of the 90, which is 0.5903. The researcher decides to use Zhang's curve to model between A and B. State one limitation of the model. I'm tired. Let me try and give a credible answer. Oh my god, an ugly question. Well, let me see if chat's doing anything. Yeah, no. What limitation of Zhang's model? I suppose. Okay, I'm gonna say that theoretically it predicts people at t is bigger than 40 hours. I'm just gonna say a thing that it does that isn't real, and I'm just gonna hope that's what they want me to do. So now I'm gonna check. First thing I'm gonna check, you know what I'm gonna check, that I've answered every part of every question. That's A, that's B. Good. Have I got A, B, and C down? Yep, looks like it. A, B, C, D, good. A, B, C, good. A, B, C, where's D? There's D. A, B, C, D, E, all good. Okay, and then on the stat side, because I nearly did it. I nearly went flying off on this one. So A, B, C is in. A, B, C, D is in. B1, 2, C1, 2, yep, that's in. Up to part C is in. Up to part C. Yeah, okay, I did that direct on paper. And this C, D, E, F. Although this was a lot more just sort of doing things. Oh, yeah, so I'll check it later. Right. So here, let's get into it. This I'm feeling confident on. U is 0, A is 3.2, T is 5, V equals U plus AT. Like nothing too complicated there. You just plug it back in like that. This is not challenging me. And also I've got 23 minutes. I want to try and do it to time if I can. So that is 16. S equals UT plus half AT squared. So half times the acceleration times T squared does give me 40. So yeah, I'm confident with that. Magnitude of the normal reaction, that is just trivially 5g. Okay, what I'm going to do here is I'm going to work backwards. If we use my value of f, do we get an acceleration of 1.4? So I've said f is equal to 21, so the net force is 7. Hold on. Let's go back to calculator setup. So 28 minus the 21 gives me net force of 7 equals ma. Does get me my 1.4, so I feel good. And find the friction to 2 sig figs. So I've said it's 3/7. If coefficient of friction is 3/7, then 3/7, so mu times r, which is 5g, does give me my friction of 21. Okay. So here, find the speed at time t equals 0. That's just root 7 squared plus 3 squared. Nothing special. Find the value of t when it's moving parallel to I plus j. Well, I found a value of t equals 2. So when t equals 2, I've got 4 minus 6, so that becomes 5. And when t equals 2, I have 8 minus 3, which is also 5, so it is moving parallel to I plus j. The acceleration is the differential of that, so 2t minus 3 and 4t, which is good. Value of t when the direction, well, let's get my value of t. So I've said t is 1.5. Plug it into there. To answer minus 3, so that's no i's and some j's, which is perpendicular to I, feeling good. So you don't need to overwork it, right? You hate memory-based stuff in physics and chemistry. So do I, which is why I try and avoid chemistry as much as possible, and why I hate particle physics in physics. But what I will say is those memory things, you can add them closer to the time, just have them there ready to go. And then the second you're done with your exams, you can forget all about them. Who needs to know about flame tests? Not I. And not you, soon. 7 weeks to freedom, not long now. Okay, so here, speed, I've done. No, I haven't done any of this. Let's check this. So let me check I CVAT'd correctly. V equals U plus A T. Tube test questions are the worst. Chemistry requires so much memorization. Like, I used to love it. Chemistry used to be my main science. And then I got to university, and within 6 weeks, I was like, oh, no. We're not doing this. We're not doing this. And then by the end, I was like that about everything. So anyway, V equals U plus A T. To be honest, this is more just checking I didn't do anything silly. So I didn't do anything silly there, and that would give me, yeah, root of 4 squared. 2 squared is 2 root 5. Yep, good. B, find the value of t. Let's plug in my value of t and see what I get. I said t equals 10. So let me find the displacement vector. T equals 10. S equals... Okay, so earth science, someone's asking earth science or material science for Cambridge Natural Sciences Part 1A. I didn't do earth sciences. Earth sciences is an essay subject, which means I went, no. Material science is not just my favorite, it's what I ended up specializing in part 3. So that for me, it's material science is kind of like, it's very practical, it's very engineering based, it's equation based for the exams. Like, that was the way to go for me. But obviously you do whatever you're interested in. But for me, the difference between an essay subject and a non-essay subject, all the difference. Plus, like, in your first year, you break apart a household appliance and kind of talk about how it was all made. It was pretty epic. I took apart a hand blender. Like, that to me was cool. That's like, I didn't like theoretical sciences. I liked applied sciences. And also, as long as we're having this chat. So in earth sciences, by the way, you have to do like little field tests where you have to like, so the way to tell the difference between like a silt and a mud or something, it's like they make you eat it. Not like swallow it, but if you chew it, you can get a sense of the graininess of it, which tells the difference between like a mud and a silt or something like that. And I didn't want to eat mud. I had a friend who did eat the mud. It was very funny. That is true. With earth sciences, you do get field trips. You do get the field trips, but I didn't want to eat dirt. I didn't want to eat dirt. Sue me. So here, let's come back in. Let's find the value of t. We found the value of t as being 10. If we plug that back in, let's consider just the I parts. In the I parts, we would have our suvat if t equals 10. The acceleration in the I parts is 2.4. U in the I parts is minus 16. What's s? S equals ut plus half at squared. So half a t squared. So minus 160. So it does go minus 40 from where it started. So it does end up on 4, which is correct. So I like that. And then if I do the same thing in the j parts, it would be, so instead of being minus 16 and 2.4, we would be doing, what would we be doing? So so u starts off at minus 3, a is 1. Okay, so what would that be? S equals minus 30, which is ut, plus a half a times 100 equals 20. So it ends up 20 higher from where it started, so it ends up on 10, and that's C. Cool. Comment question. I find math way too easy. I've never been close to the A-star boundary. But in physics and chemistry, I'm always on the boundary or near it. It's nerve-wracking given you need 3 A stars. Okay. Analyze. Comment question. Let me stop sharing screen. So what I would do there is I would analyze where your marks are being lost. So I always like to break out your errors into conceptual errors versus execution errors versus exam technique. If you're losing because where you're losing your marks tells you how to do your targeted revision. If you're losing them conceptually, it's just hitting the books and picking up the knowledge points. If you're executing badly, it's just about practicing the questions over and over again until the skill becomes nice and strong. And if it's exam technique, it's just doing lots of exams and learning what your mistakes are. Are you reading the question well? Are you checking your axes to make sure you're not falling into any units trap? If you're dealing with gravitational fields, are you measuring from the surface or are you measuring from the center? Pick up these mistakes. And that way, when you're moving through, you're going to be like, I'm not going to do that, not going to do that, not going to do that. And then it'll kind of fall into place. So that's my advice there. Hopefully over the next 7 weeks, you should see your marks sort of slowly track up if you take that on board. So really, you could even keep a log. If you go through all the past papers you've done, keep a log of these small mistakes you make, study that. And then the next time you go through a paper, you don't make those mistakes, your scores improve. So let's go back to the checking. So I'm satisfied with this. Question 5. Show that I did. Show that I did. Let me just confirm that tan alpha equals 3 is a solution to that. So I'm just going to say 3 squared minus 12 plus 3 is 0. So tan does equal 3. It does not equal 1 because that would predict that A is greatest height, which it isn't. So the greatest height, that does become root 10. So sine is 3 over root 10. You're saying I almost, actually, let me just check this and then I'll come back to comments. So that's sine. And then in this vertical suvat, so that times 28 is the vertical. So V squared equals so 0 equals, so I should get a clean 0. U squared plus 2a times the height I got of being 36. Is this a clean 0? Yes. So my height of 36 is good. Limitation of the model, I don't care. So following up on the comment question, I almost certainly lose a couple of marks on just calculation errors, and it isn't improving. A couple of marks are always weird and can't be done anything about it. Okay, so if you know you need to include some buffer for the weird questions, it means executing on the calculate. Okay, so when you say calculation errors, you're going to want to categorize what kind of calculation error that is. So is it a case that you understand what calculation is supposed to happen and it's just going wrong in the calculator? Or is there something more conceptual? For instance, when you're doing mole calculations in chemistry, are you forgetting to go to the equation, the chemical equation to get the ratios? Is it about contextualizing your number? So you see a number and don't know what it means, so you use it wrong. So for instance, when I'm doing mole calculations in chemistry, I don't just put the number, and I don't even put the number and the unit moles. I say what it's the moles of, like that's this many moles H2SO4. So whenever I go back to it, I always go, that's the number and that's what the number means. So in these applied sciences, contextualizing your answers might be what you need in order to help piece things together. So really dig deep on why you're losing these marks. Right. Okay. So if you forgot to find the concentration used for pH, that to me is execution. That means you understood what you were doing. You went, oh yeah, sorry, I should have done that. That is, to me, is an execution error, which means you want to find that skill and just rep it over and over again until it's like in your muscle memory. So I would go like topic by topic and just practice individual skills until you're completely nailed down on the procedures. And then your percentage of making that error will decrease over time. Okay. Right. Finally, let's get in and check out this question 6. Very, very welcome. All right. So here, say the direction. Yep. Show that I did. Find mu. Guys, I'm feeling kind of good about this. Like I'm kind of not in the mood for checking, but like I'm gonna check because you need to know how to check. Checking is just more fun in the pure. And the applied is like, okay, whatever. But here, okay, so if we were to use my mu, do I agree that if 10 is equal to that, then sine is 3/5 cos is 4/5? Yes, I do. Do I also agree? Well, let me just plug that in here. So that would be a half. So tan is 3/4. And that's 1 over 2 answers, so that's 2/3. So it is 2/3 mg. That is S. Okay, so that's 2/3 mg, which means that's 2/3 mg, and that's mg, so mu just is 2/3, trivially. Find in terms of m and g the magnitude of the resultant force. Well, that's the square root of 1 plus 2/3 all squared. Two-thirds squared, yeah, root 13 over 3 mg. Cool. And then E was just to do it, so that's not too bad. So the mech paper, not bad. Stats paper, let's get back into it. Theoretically, I have 8 minutes left, but I spent some time chatting, so I'll give myself some leeway. Find probability of A, 0.38, you add them together. What I'm going to do here, this actually is interesting to check. Let me say, if I have my values of P and Q as given, first of all, would everything sum to 1? Second of all, would it give me independence? What's happening right now is I am checking my answers for a Stats and Mech paper for Edexcel June 2023. So I've done the paper run. I'm just checking it up, and then I'll mark it, and then we'll wrap. But also, as always, feel free to drop things in the comments, and I'll just answer them. So 0.13, 0.25, 0.05, 0.3. Okay, and then I found my P and Q from earlier. P was 0.2, Q was 0.07. They do add to 1. Great. Now, would P being 0.2 give me independence? Well, that would mean 0.5 times 0.6 would give me the 0.3, which is in the middle. So that is just correct. So I'm happy with that. Find the probability of A given not B. Well, not B is just 1 minus everything that B is. So 0.25, 0.05, 0.3. Yep, so out of that 0.4, we're looking for the bits that are A. So it's 0.13 over that, which is 13 out of 40 as given. Good. So here, stated condition, I did. This stream was randomly recommended to me. So you were like, oh, what's going on? Discussing your paper. No, my paper. No, my paper. God, no. I did my paper in 2012. Okay, so these are your papers. Yeah, I mean, hey, it's exam season, so people are like, tis the season. I'm very happy to have you guys. Like, you know, you can always recommend things that you want. You can also ask random questions for whatever level you're at. So if you've got some university advice questions, feel free to drop those in the chat as well. Right. So here, binomial. Let me just confirm I didn't do anything silly. Exactly 6. That's binomial PD. Variable. So it's exactly 6 for 40 and a 7th. I get, yep. Fewer than 3 is less than or equal to 2. And in fact, I could bring is this the time to bring this across? Because I kind of just want to see how it would have worked in here. Would it be stats, or is there a separate distribution? Let's say it's, oh no, distribution is there. So distribution, binomial. No, I want equals to. Oh, I hate this calculator. Oh, someone's doing finance. Would you be able to help me with regression and hypothesis? Ironically, you're in just the right place, because that's kind of what we're doing. So hypothesis testing is this exact question that I'm going over now. I suppose it might be a little bit different. So regression hypothesis testing, are we talking about, like, it depends on which correlation coefficient you're using. Hypothesis testing for correlation really is just a case of finding out what your correlation coefficient is, comparing that to a critical value you find in a table, and deciding whether your tested result is statistically significant. So, yeah. Oh, if you can start teaching econ on this channel, I cannot start teaching econ on this channel. I do not know econ, and I found that out the hard way when I tried to teach econ and was like, but what? Like the fundamentals kind of make sense, but in terms of like any exam technique, events like how to set up the essays to get like the 8 mark versus the 12 mark versus the 15 mark versus the 20 mark with all the like evidence, evaluate, analyze stuff. That's not me. that is not me. I'm math and science guy. Can't be doing econ. What is money? This is teaching. There is no money. Okay. Let's get back into this. I should know why am I having troubles with this binomial silliness? Is it this one? X equals. Okay. So x equals. Let me make you small. So on this one, x equal. Stop doing silliness. I don't want computer things. Go higher. Whoop. No, close enough. I'll just never put in a 0. Oh, thank you very much. And you with yours. Right, so x is 6. Num trial is 40. Probability is a 7th. Execute 0.1727, all good. So fewer than 3. Let's check how that would work. So how do I go back? Okay, so let's change the trials now to F1. So less than or equal to 2 this time. Let's execute. That is 0.615, they're saying. Okay, so it's basically what I said. Yeah. This way, so like there's a couple of calculators. So I'm going to do the checking on the CG50 just to make sure that my my 991EX was all good. So now that probability went into this. So I said that it was distributed with 5 and that answer. Find the probability that exactly. So we're going to go back. Delete. No. Exit. That was it. So we're going to go back into here. Going to do an equals again, where x is equal to 2. Num trial is 5. Probability. I'm going to use the same probability as before, actually, as being 0.616. I'm going to execute that and make sure I get something similar. 2148. No. It's because I got the wrong probability. Let me exit out. So that should have been 0.0616, which is yes. Okay, cool. Hypothesis test. Probability is a 7th, or probability is less than a 7th. 110 at a 7th. You get an actual value of 9. So, okay, let me exit and sort that out. Yep. No, stop. No, stop. Cool. No. Why? Okay. Guys, tech hates me. It's so not fair. Okay, so less than or equal to 9. When the number of trials is 110 and p is a 7th, you get 0.03, which is less than the 5%, so it is significantly good. In theory, I'm up on time, but like, screw it. I was chatting. So here, I'm happy with what I did there. Estimate the mean. This really is just calculated, though. No. So let me go back to, no, not shift. Menu? Yeah, menu. Calculate. I like calculating things. Calculate. Cool. So here, 390. No, I'm not going to use divide signs. So 390 over the 184. You just kind of rerun it. 2.12. Good. Root of 4336 all over 184 minus answer. Where's squared? Where's the squared? Are you kidding me? They don't have squared on this calculator? What is that? You see, for being a fancy calculator, it's really not that good, in my opinion. And then there was just a bunch of words. For, okay, we're going to go back to the distributions. I don't know, I lost the distributions. There we go. So let's do normal this time. Let's do taller. So x is bigger than 180 for a standard deviation of 6.8 and a mean of 175.4. 0.249. Yeah, so it's differing in the fourth decimal place, but I think that's okay. So here, this time, let's go back. So in this case, we're going to take the mean. So the mean, so we got 177.2, and the mean should be 175.4, but the standard deviation should be 6.8 over root. Nope. Over root 52. And if I execute that, there is a 2.8% chance of being bigger, but it's 5% in two tail, and it is different. Yeah, that's good. P-value, I have no idea what that means, so good luck to us. For this one, it's going to be, this is just pressing buttons, so I'll show you what I would do. I would just, first of all, make sure that everything I found satisfies the conditions that I was given. So show that. I did show that. So find the probability distribution of x. So first of all, do these things sum to 1? I showed earlier they do sum to 1. Do these things sum to 1? Yes, they do sum to 1. Is this the case where it's a k over x? So multiply this together, you get 400, 400, 400, 400. Good. So that is true. Probability that S and they succeed is the same. So in other words, it's not likely. So A should be less likely than D. So it should be getting progressively more likely, which it is. Okay, this all works. Hello, hello. I'm satisfied. I'm satisfied with this. And then we get into the silliness that was question 6. Use the histogram to estimate the thing. Kind of tempted to just check it at this point. But the way to do that is to get the area divided by 90. So is it true that's 2 by 4.2, which is 8.4. 4 by 4 is 16. 3.5. I'm knocking off a 0.5 times 5. Yeah, that tracks. That tracks. So let me just make sure that the... Yeah, I think my checking technique is just better, I think, when it comes to pure. There's less to plug in the stats in Mech. But I'll just make sure that the 8.4 plus the 16 plus the 14 plus the 10 over the 90 does give me what I said when it does. B is words, C is a show that which I did, D is a show that which I did. Find some probabilities on it. At this point, I'm just gonna say I got it right. I'm happy with how I did E part 2, where I ran it and then divided it by... Yeah, I'm just going to check it. I think I'm going to check it. I don't think this is adding much value. So at this point, let me stop sharing screen. Let me get the sort of setup done, where the mark scheme is split out. Hold on. Oops. So that is going... that's not where that's going. I should never be led around tech. I'm honestly diabolical, guys. Right, so the mark schemes are up. Share entire screen 2. Mark schemes up. Let me get the results. Cool. Scrolling back up. Yep. Okay, A is 16, then 40. Good. 5G, good. 21, 0.43, great. Root 58, t equals 2 only. We got that vector. We got that time. Good. 4. 2 root 5. Good. T equals 10. Good. C is 10. Good. Now we get into some wordy bits. Maybe not some wordy bits. Where the wordy? Oh, that was D. D is wordy bits. Show that I did. Show that I did. Solve that. 36. Boom. Love to see it. Spin of the ball. Does not consider spin. That's in there. Yes. Dimensions or shape. Yep. Great. And then question 6. So it's trying to... Normal reaction is acting left, so it must act right. That's one answer. Right, as it prevents the rod from sliding left. Good. Show this. I did. From the moments. Love that. Resolving, blah, 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 blah. Yeah, mu is 2/3. Great. D. Yep. And then, yes, the new value of S is larger as the moment of the weight about A would be larger. Great. Which is what I said. I didn't write it down because there were just too many words. But that is all of that done. Then the stats. Let's make sure everything's fine there. Especially the wordy bits. I hate the statsy wordy bits. But let me scroll right to the top. So 0.38, 0.2, 0.07, 13/40. Yep. Question 2. Overshot the mark. Okay. Stated condition. Independence. Great. 1727. Yeah. 616. Good. Find the probability of this thingy. So C, it was 0.0313. Good. D, yep. Reject, and there is evidence to support the claim. I said, but also, guys, really pick up on the language of this. So there is evidence to support the claim. It doesn't mean they're right, but the evidence supports the claim. So I probably went a little bit too much on my conclusion there. I'm so curious what they wanted wording-wise for 3A. Trace it with a numerical value. This should presumably... That's implicit in this. So it traces between 0 and 0.5. Perfect. Okay. Then you get 2.12, 4.37. This only covers May to October. So the winter months are missing when you'd expect more rain, so it's less than the actual. Great. 4, 2, 4. What was A? It was 0. Yeah, 2. Good. So here, mean, yep, two-tailed. Good. I got my new standard deviation. 0.281, perfect. Sorry, 0.0281, that's all good in there, so that's not significant. So you do not reject H naught, insufficient evidence to support the claim. So look again at that language, that's the way to phrase it. The p-value is, yeah, what is that? Why is it 2? Presumably that's in each tail. So that's interesting. That p-value, they've taken it, so they've, I genuinely do not remember seeing this in the syllabus anywhere, in like the textbook, but they seem to have multiplied the value I found by 2 to find the probability of being that extreme or more in either tailed, given that this is a two-tailed test. And because that thing is bigger than the 5%, that's why you don't. So it's kind of the opposite of when you split the 5% into 2.5 when you're considering one tail. This is almost like taking your probability, doubling it to put it back together again to compare it with the 5%. So that was a genuine conceptual issue I had with that, and I did not know that was there, and it's good that I know it's there now. All right, so they just did this in terms of K. I solved for K, which is why it took such a long time in A. But yeah, so I did get that. I did get those A, B, C's, D's. And because I did it precisely, I actually got a proper probability to compare. Which I think should presumably be okay there. For using K equals 30. K does not equal 30. K equaled 400, didn't it? (400/37). What? Oh, they're defining K different. Don't really know what to make of that. What did they do? Oh, they got the K equals 30 from his experimental results, not the true from the, yeah. So if this was true, then the K would have been 30, but if I use K equals 30, the probabilities do not sum to 1, so it doesn't work, is their argument. So at no point did they do what you usually do, which is solve K by adding up the probabilities and equating to 1. I'm going to claim myself as being correct. Then question 6. 121/225. Good. Now we get into the fun stuff. Not suitable. It's not symmetric. Yeah, data's not symmetric where there is positive skew. I did solve that. The required area equals 90, which is how I got the 99. So I did show 99. These probabilities, I got that one right. I got that one right. Patients might stay longer than 40 hours. Good! Predicts people at T bigger than 40 hours. Yes! Okay, and was that it? All right, that was it for the paper. So hopefully that kind of is good to demonstrate how I would move through papers like this. As usual, keep dropping things in the chat. Keep leaving things in the Discord server if you want specific things recommended. Like I say, the really interesting thing is the checking side, which seems to be a bigger thing on the pure side, but hopefully you got some good things about how to like work in both calculators. Yeah, honestly, I say crack on. Keep doing, like, we're into proper exam season now. So I know the IB physics starts tomorrow, which is very exciting. So it's just lots of past papers. Like, you've done all the learning. Keep doing past papers. Check up on your skills. Make sure you're able to execute your exam plan, your exam strategy. See if you can, like, there's always something more to push for. You can always push for getting there faster and accurate, giving yourself more time to check and using that time to check a bit better. Get diving into the individual skills so you build up that execution consistency. There's so much you can do to analyze your results before and after a test. So really, every time you sit down and do a past paper like that, sit down, analyze your mistakes. So it's, for me, I was like, oh, that p-value, I now know that because I got it wrong. Doing these past papers, doing this sorts of post-game analysis, and then improving your game is exactly what you got to do. But right, I'm going to leave it there. I'm going to be doing a physics stream at some point this week. It may be Wednesday, it may be Friday, or it's like Saturday. We'll see. And in the meantime, I will see you then. But until then, take care and enjoy your revision. Work hard, have fun. See you next time.